Dear viewers, something unusual has occurred in astronomy. An interstellar object known as 3IATLAS has become the focus of observations that have puzzled both experts and space enthusiasts alike. On November 9th, 2025, astrophotographer Frank Nebling captured an image that clearly shows an extended glowing tail structure and, most peculiarly, a jet directed straight towards the sun. The photo reveals a complex tail architecture not previously seen in visitors from other star systems, reigniting questions about the nature of 3IATLAS. This observation coincided with the publication of an article by astrophysicist Avi Loeb, Harvard, on the Medium platform titled The Large Antitail and Jet Structure of 3IATLAS. In his work, Loeb examines the unusual configuration of streams around the comet in detail and raises a series of questions about its essence. Is it an ordinary interstellar body, or, in theory, something far more complex, such as an object with its own propulsion systems? However, the scientist himself does not engage in baseless speculation. His hypotheses are grounded in observational data. Loeb emphasizes that 3IATLAS largely behaves like a natural cometary object, but its acceleration, changes in brightness, and the appearance of multiple tails demand careful study. Frank Nebling's photograph is truly impressive. It reveals two key details: a broad, fan-shaped tail receding away from the sun, and a thin, focused stream of material directed towards our star. This combination has baffled astronomers. Typically, comet tails always point away from the sun due to the pressure of sunlight and the solar wind. Observing a jet aimed at the sun is rare. When it does occur, it's usually explained by localized activity on the body's surface. In this case, the geometry of the image doesn't provide a full explanation. We are seeing not merely an optical illusion, but multiple, strikingly distinct jets in the frame. The long tail, sometimes called an antitail, stretches for millions of kilometers. Its apparent shape is often due to the specific alignment of the Earth, the comet, and the sun. When Earth passes through the comet's orbital plane, a thin blade of the dust trail can appear to point towards the sun. But in the case of 3IATLAS, simple geometry doesn't explain everything. Multiple streams and layers are visible, making this more than just a familiar optical effect. A key point is that 3IATLAS is an interstellar object. It originated from outside our solar system. Before it, the only confirmed visitors of this kind were two bodies: Oumuamua in 2017 and 2I, Borisov, in 2019. Each surprised scientists in different ways. One demonstrated anomalous acceleration without a visible tail, while the other resembled a regular comet, but had an extrasolar origin. 3IATLAS combines characteristics of both visible activity and strange ejection structures. Coupled with unusual dynamics, the object has been tracked since mid-2025. It has already displayed behavior that challenges existing models. A slight but noticeable acceleration. After perihelion and radio signals picked up by the South African Mercat radio telescope, these radio signals are consistent with the presence of hydroxyl radicals, evidence of water vapor release upon heating. But the latest images reveal previously unrecorded phenomena: a large-scale antitail and a sunward-directed jet. In his work, Avi Loeb explains that if this is a fully natural object, the sunward jet could result from uneven surface heating. When sunlight hits local ice deposits, sublimation occurs. Gases and particles erupt at high speed, and due to the comet's complex rotation, these jets can temporarily be directed even towards the sun. However, Loeb notes, if the jet's orientation changes in a way that cannot be linked to normal rotation or heating, other explanations would be required. He stresses that such observations do not imply an artificial origin, but they do create a basis for more in-depth scrutiny. The Galileo project, coordinated by Loeb, has been monitoring interstellar objects for several years, searching for distinctions between natural behavior and potential technology. In the coming months, astronomers plan to intensify observations. 3IATLAS will approach Earth in December 2025, providing an exceptional opportunity to study its composition, ejection dynamics, and trajectory. The European Southern Observatory's VLT, the Hubble Space Telescope, and possibly JWST plan to acquire additional images and spectra. In March 2026, the Juno spacecraft, currently near Jupiter, will aim its radio equipment towards 3IATLAS as it passes roughly 53 million kilometers from Jupiter's orbit, a chance to verify the presence and nature of the radio emissions noted earlier. Spectroscopy of the images indicates a difference in composition. The gas jet directed towards the sun consists primarily of carbon monoxide, CO, with traces of ammonia, while the dust fan is made of fine particles scattering sunlight. This differs from typical solar system comets, which usually have a higher proportion of water ice. This combination, intense dust activity alongside gas jets of a different composition, gives 3IATLAS a distinctive profile. Several points concern scientists. First, the jet's orientation. Components pointed towards the sun usually dissipate quickly when interacting with the solar wind. Yet here a sharp, bright formation persists, possibly due to high particle density or a different mechanism. Second, the almost perfect symmetry of the antitail requires uniform and stable rotation, unusual for a small body moving at speeds around 100 kilometers. Third, accumulated data from October showed a slight acceleration after perihelion, initially attributed to jet forces from outgassing. But further observations will test if these are sufficient to explain the velocity change. In his article, Avi Loeb reminds us that the scientific method is about following the evidence wherever it may lead. 3IATLAS is a unique laboratory for studying interstellar bodies. If its activity is entirely natural, we will learn how ice and dust withstand interstellar travel. If there are anomalies that don't fit currently known mechanisms, it will open the field for new hypotheses. Recalling the case of Oumuamua, where the acceleration lacked a definitive explanation, Loeb emphasizes that researchers now have an advantage, more advanced instruments, and the ability to obtain spectroscopic and radiometric data as it approaches. The object's brightness will increase, and by December 2025, 3IATLAS will be accessible even to advanced amateur telescopes in the constellation Capricornus. It may appear as a faint, diffuse glow. Professional observatories will analyze its spectra, searching for unusual isotopes that confirm its interstellar origin. Each observation is another piece of the puzzle. Such interstellar guests are rare. Statistically, only 1 or 2 every few years become detectable with our observing means. 3IATLAS stands out because it is active, prominent, and favorably positioned for study. The more data we gather on its velocity, direction, and ejection composition, the more accurately we can determine whether natural mechanisms suffice to explain its acceleration, or if additional forces are at play. In the coming months, publications with results from various instruments, from arrays like Atacama and Mercat to space telescopes, will help form a clearer picture. For now, Frank Nebling's image remains one of the most spectacular portraits of an interstellar visitor ever captured. A bright and dynamic snapshot of a wandering body, frozen in a moment of unusual activity. If you're interested in evidence-based observational discoveries, subscribe to the channel, like this video, and share it with those who love astronomy. Together, we can follow this story's development and discuss new data as it emerges.